studio. Let me introduce Dr. Vijay Govindarajan of Tuck Business School. He and his team have been studying how innovations happen for over 40 years, and here's his key finding. It is that well-run companies are structurally incapable of innovating internally. Right? The leaner your staff, the less time any of you have to think outside the box. So, what if you want to follow up on one of the solutions you see today? So you're just going to call the supplier and say, come on over and install that puppy? Or do you measure? Do you think? Do you investigate? And if you're busy right now, when are you going to squeeze that into the schedule? Well, the MEP system exists to address that need with over 1,200 consultants in over 400 locations across 50 states dedicated to helping you solve manufacturing challenges. The Oregon MEP Center is called OMEP, and its mission is to help manufacturers become more competitive in a global marketplace. They are results-oriented. For each focused engagement, they ask themselves tough questions like, did we help you grow your business? What processes were improved? Your success is the metric for OMEP's success. So, if you find yourself ready to take action, but wondering where you're going to find the time to even get started, consider giving OMEP a call. You can find them easy. Just look up MEP on the web, click on the map, find the number, give them a call, and you'll be all set. So thanks for that, and let's move on along to the next place. As I said earlier, we tried to squeeze all we could out of the last half hour, but we didn't quite get there. We have to speed things up. And so, Linda, can you please join us? And by the way, Dan, well, I guess Dan and Sam are gone, so I won't ask them to come back because we need to keep moving right along. So, Linda, tell us what you got for us. Where would you like to start this before we pop you off into your slides?
First slide is good.
Okay.
It's always a good place to start.
Well, first off, tell us where you are. It looks pretty interesting back there.
Oh, I'm in lovely Dallas, Texas.
So you're at some.
Or it's about 2 degrees here.
You've pulled yourself away from the trade show to share your time with us. Is that right?
I did that.
Thanks very much. Appreciate it.
Yeah, so I appreciate your asking me to be on this webinar. Clean water technology has been around since 2004, actually much earlier with other products. But the GEM system stands for gas energy mixing, and it's used in place of dissolved air flotation. DAF technology has been around since World War II. So, you know, and while DAFs are getting more and more efficient, smaller footprint, the GEM system actually approaches solid liquid separation significantly different than dissolved air flotation. What we're doing is we're injecting air into 100% of the waste stream. We've got a much smaller footprint. We're using chemicals more efficiently. So I'll get into a little bit more of that. Just kind of on a broad spectrum, CWT also does provide anaerobic digesters, membrane bioreactors, so all the biological treatment systems, filtration, ultrafiltration, and sludge press equipment. We've just come out with a very, very solid sludge press, usually needed to dry sludge off of biological systems. For the GEM system, our sludge is fairly dry, and I'll talk about that a little bit more. But yeah, so we do provide the complete treatment systems for our clients. Just an example, here's our sludge press, a couple GEM system 1200s that were used in a meat facility. We do meat, poultry, pulp and paper, even car painting, car facilities. So it's a very, very good system. So basically, what is the gas energy mixing system? As I mentioned earlier, it's got a lot smaller footprint. These units were both sized between 150 GPM. As you can see, we're a fraction of the footprint. So at this point, I think I'd like to run to the animation. If you could do that for me. Excellent. It should be starting. It hasn't started for me. Oh, there it is. Okay. So here it is. It's a skid-mounted unit. So everything is available on the skid. You've got the basically control panel, your sludge tank, your sludge hopper, and your air compressor, water pump, sludge pump. What happens in the system that makes it different than dissolved air flotation is we're injecting air into 100% of the waste stream. So you see this first head. We're sending the waste stream through that head, and what we're doing is we're doing it under about 110 psi. We're also adding polymers. Now you can add them in any one of those heads. As you'll see, they run in a series of 6. And so we're going to inject the polymer in, like I said, any one of the 6 heads. We use a dual flock approach usually. So that means, well, I'll get to that later. But actually, we're able to expand our system up to twice the size of the minimum usage. So by opening or closing those heads that you saw, the little plugs, we're actually able to increase our flow. So the flocks, as they come into this chamber or the cylinder, the polymers actually are coiled up. Polymers stay coiled up generally, and when they do that, they're only attracting waste particles to the outside. CWT has a patent on uncoiling that polymer. So what we're doing is we're opening up that polymer, availing more than 2 times the charge site, so that we're attracting more waste particles per polymer. And later you'll see that as those polymers close, because they tend to have a memory, they'll close back up, they're going to self the water. They're going to actually take some of that water out of the sludge. So you're going to have drier sludge than conventional DAF technologies. And as you can see in this in these heads, they're in series, and in each head we drop the mixing speed and energy by 10 to 15 psi. So particles that didn't attach earlier on are more able to attach at the slower velocity. Then what we have here on the left of the tank, where it's white, is the blue chamber. Basically, we're dropping that pressure down to just about nothing. And as we do that, the flocks just pop up almost like popcorn to the top of the tank. As you see, we're lowering the pressure. They're popping up. A lot of the flocks are dewatering. And then as they get up towards the top of the tank, really they continue to dewater. So we're only using that tank just in solid. And that's why our footprint can be that much smaller, because we're not using the tank for anything but dewatering the sludge, or, pushing the sludge out. So I think we can go back to the slide. So again, it looks crazy that a small system like that could take the place of a larger system, but it's technology that's actually been around in the mining industry for many, many decades. And, we just happen to be the first company that brought it here. And we've got several patents that I'm going to talk about a little bit. But first I'm going to tell you pretty much the difference. As you saw on that skid unit in the animation, everything is on this. It's a plug-and-play system. You've got the control panel, the chem mixing system, skimmer blade and motors, sludge hopper, air compressor, water pump, sludge pump. So everything that you need is in the system. Here's, again, an example of plug-and-play. They've got the water pipe going right into our gen system. We clean the water, it goes right out. It's pretty easy. We've got many, many sizes, anywhere from below 30 GPM, like 5 to 30 GPM, all the way up to 1,800 and beyond. We can do custom size units for you. Again, they're expandable, they're movable, they're skid mounted, and they're basically plug and play. Plus, we do a lot of the design for you. That's part of the job, and I'll kind of get into that a little bit further. But first, I'm going to talk about our patent. Again, I mentioned that we're dissolving air into 100% of the waste stream. The reason why that's important is because as we do that, we're creating many, many more bubbles than would a dissolved air flotation unit, which generally recycles the stream and adds air kind of in the tank to help float. We're injecting that air at the very beginning. So we're creating about 10 million bubbles versus maybe about 2 million bubbles. So again, waste particles like to attract to bubbles that are the same size or smaller. So by creating very small bubbles and by having more bubbles, we've got a much better chance to attract way more waste particles or more contaminants. The second patent, again, is on the chemical efficiency and mixing. We've got very stringent control over the chemistry dosing, the mixing time, and the mixing speed. In each of those heads, we can make that happen. The next is, again, our bubbles expand because we're using a flock dewatering technique. In a dissolved air flotation unit, the polymers and the waste particles generally, rely on the collision method to sort of bump into each other and then use the air to float. What we're doing is we're proactively separating that in our LSGM heads or our GEM technology. So by the time our solids hit the tank, they're already separated. Again, some of the operational things, as Cliff had mentioned earlier, operational costs are, just as important as capital costs. Basically, we're creating much drier sludge. We've got, I mentioned that the polymers close back up and squeeze out the air or the water, but also our sludge, because of all that air that we're introducing, it continues to decant over a number of days. So if you put it in a cone bottom tank, it's going to decant, up to, it could be 10 to 13% off the beach, depending on your waste stream. Obviously, every stream is different. But it can decant up to 20, I've even seen 30% or more. So it's pretty phenomenal. And if you look at sludge costs, almost 77%, this was a study done in 2008, and about 77% of people's costs, wastewater costs, were related to sludge hauling, sludge disposal, sludge drying. So that's why it's so important that we have such drier sludge. And you can see here, GEM versus DAS in very different industries, dairy, pet food, frozen foods, and even oil. Our sludge is more than 2 times drier. So that's serious money. It's less trucks on the road. It's more sustainable. It's important. And here's just kind of a different setting of sort of all the different types of sludge we see in different waste streams. So then we get to chemistry. And I'm sorry, but I have to have a sip of water. Do I have water time? Okay. So basically, again, we're doing reduction rates. What happened? Okay. We're looking at reduction rates here. Again, different industries, same as before. TSS, we're getting, significantly better TSS removal and COD removal in the various industries. But the important thing to look at, too, is we're using a lot less chemistry. So that, again, is serious money in your pocket. The chemistry we use is available through any supplier. So, for instance, if you've got your favorite local supplier, we do like to get wastewater samples and talk to the chemical supplier about what should be supplied, what the best is, because running a jar test at a job site is not the same thing as what we do at our plant. And so what we do is we ask our clients to send us a sample of their wastewater. We have a PhD chemist who specializes in flotation, flocculation, and chemistry. And we will run TSS, turbidity, COD, and we can run BOD and FOG as well. This is important because, again, it's not like running a jar in the field. We are actually mimicking what's going to happen with the GEM system in our laboratory. So when people say, well, we've already got data from our city or whatever, that's great. It's great to have so we can look at trends, but it's also very good for us to get a wastewater sample. We provide free of charge a report that shows the client removal rates that they can expect and expected amount of dosing. So it really helps us help them figure out their operational costs. Again, this is just sort of an example of different lab results, different industries. Using very little polymer, we're able to get incredible reductions. 98% total suspended solids reduction. You know, I think everybody speaking today will agree that a primary treatment system cannot reduce your dissolved BOD. It's just part of life. You need a biological system for that. But if we can get out 98% of your total suspended solids, or 99%, I've seen 99.9%, we're able to get out, you know, virtually all of the non-dissolved BOD. So all you're left with is, you know, the BOD, which can ultimately reduce your secondary treatment, your biological treatment size. A GEM system costs somewhere between $150,000 and $500,000, depending on whether you're buying the screen, an EQ tank, all of the things that you would buy with any primary treatment system. And biological systems are much more expensive, so obviously if you can make it footprint smaller, you're going to be able possibly to save money on your biological system. We also have demonstration units. We have worldwide offices, but we've got several demo units right here in the U.S. that we send out to job sites. This actually is, the picture you see is our 2075 GEM system, which means it goes from 20 to 75 gallons per minute. For demo purposes, we ramp that down to 10 GPM. And as you can see, we've got a sludge, little barrel collecting the sludge, so that we can actually look at that overnight and see what the decant range is and what the percent solids are. So we're providing the client with a very detailed report of chemical dosing, expected results under different dosing parameters, and the kind of sludge they can expect. Again, people have been amazed that the water looks drinkable. Of course, I don't think you want to drink it, but we make very, very clean water. And we also retrofit existing DAF. For instance, if you have a DAF that, you know, is not that old, the tank is in good shape, we can basically just take our GEM technology and kind of add it to the existing DAF. And because everything's done in those heads that I showed you, that you can see on this picture, we can get 2, 3, 4 times the hydraulic capacity and contaminant loading out that you weren't, you know, for a DAF that's been maxed out due to hydraulic loading. One thing that's important to note is that the GEM system is sized only based on hydraulic loading. It can handle anywhere from 200 to 12,000 ppm of fats, oils, and grease, or the TSS, it's the same size system. So while you're conserving water, your clients are conserving water, they're going to have an increase in contaminant loading in their water. You don't need to get a bigger system. The same size unit's going to help you. So it's very important to note. Clean Water Technology has a very good website, so please visit it at cleanwatertechnology.com. On that website, we've got several case studies. We also have additional case studies, so you can always contact me if you don't see what you're looking for here. On our website, we also have a number of papers. We're a key presenter at WestTech and a lot of international shows, so we'd be happy to share any of that with you.
So, Linda, that was terrific, and we're sorry to miss you. Your camera turned off. Can you take a moment and turn your camera back on while Sam and Dan are joining us as well?
How long is that enough?
A couple minutes, but we have the nice title slide, so everybody knew who you were. Nothing to worry about. Do get it turned back on again, though, because chat was really, really active during your remarks, and I'm going to rely on Sam and Dan to sort of ask questions on behalf of the audience. By the way, I really, really like that background, and you look great. And I think they're looking. As far as I've heard, they're looking for help at NBC News. Maybe there's the future for you. Okay,
Linda,
Sam, Dan. Go ahead, Sam.
Thank you so much, Linda. That was a great presentation. I appreciate that. One of the things that was asked by some of the people in the audience and myself, I'm curious to know, too, what the requirement is to remove particular particle size before it enters your GEM unit. I know that you probably have an issue of not wanting certain size particles coming through the process, but you have to do some pre-treatment before going through your unit. Is that correct?
Well, yes and no. It's no different than any other like dissolved air filtration unit. You're going to want to screen out those big solids because you don't want them getting in your motors. And, you know, I mean, there's some weird stuff in wastewater. It's not just, I mean, we've gotten like gigantic hoods, big hoods going through the system. That's not, no wastewater system is made for that. So yeah, you generally want to have a screen, and adjusting pH in some sort of EQ tank is good because as you get that pH dialed in, you're gonna have more efficient chemical usage. So instead of chasing pH and having to adapt all the time, we like to dial it in, and that saves the client money as well. But yeah, so it wouldn't be any different than normal.
And that would be typical in a treatment system to remove, you know, gloves and bags and things of that,
Exactly.
plastic, you know, particles of a certain size that are, you know, pulled out by a rotary drum screen or something like that.
Mm-hmm.
Go ahead, Dan. See, you got one. Go ahead.
Dan, you're
Dan, you're muted.
Oh, sorry. Yeah, the mute button is handy to use. What is the energy consumption compared to a typical DAF of a similar size?
It's no more energy. You know, it's just it's the same. I have not seen that it's any more. All we do is, you know, we've got the air compressor. All those things are skid mounted. You just plug it in, and it takes up the same energy as a standard conventional DAF.
I like the
Sometimes
idea
even
that
less, actually. What's that?
I was going to say, I'm sorry for going over you, but I like the idea that the waste sludge would be, you know, aerated a little bit more and therefore have less water in it and decant pretty nicely, and that's a really good advantage.
Mm-hmm.
So with a higher sludge concentration, what are some examples compared to a DAF?
You mean in terms of percent solids or?
In terms of percent solids.
Well, and Dan, you might want to step in here because I may misspeak, but what I've been told is that DAF solids tend to be about 3 to 7%, and they don't really decant after they're discharged, whereas we're about anywhere from 8 to 15% solids off the beach, and then it continues to decant over a number of days. Now, I mean, obviously some DAFs might have drier sludge, but that's basically what I've been told.
The concerns about filtering out sand and soil particles continue. Is there any effective treatment for sand, or should that be removed before it goes into the GEM system?
Sand is kind of interesting because it's not really a floaty type of object, but you know, there are chemistries that can, with the GEM system, that can actually attach those particles. Now, sometimes, I mean, it's always a good primary treatment. Is it going to get 100%? I don't know. That's why we like to test the wastewater, too.
In typical DAFs, and I think in the GEM, you also have a bottom drag out for the solids that may not float. So there's an opportunity to remove solids from the bottom.
We do have
the Dairy Gold one in Portland had the opportunity to remove solids from the bottom.
Yes, absolutely. But you honestly don't really need to. I've had clients who never have to clean out their system. But I do have some clients that are pretty insistent on not using any chemistry. So even though it only takes like 5 or 10 ppm of a certain chemistry to get, you know, really good removal rate, some of them don't want to use chemistry, and in that case, you might need we've got another design that has a V-bottom and an auger.
So this is Skip jumping in, and I unfortunately have to be the clock Nazi yet again. This is really good stuff, and there are more questions that haven't been answered. What I'd like to suggest is that anybody who has a question, keep chugging them into chat or put the questions in the evaluation that we ask you for at the end, and we'll get Linda and the other presenters to address all those questions offline, the ones that haven't been answered here. So let's let's keep moving along. Linda, thanks so much. This is great stuff. Don't go away yet. I do want to say thank you again, but let's attend to the panel. And gentlemen, we have 3 minutes to do this. First, reality check. How are we doing at serving the audience? Are we getting it, or is there anything we're missing?
I think it's important to know that the GEM system, as well as a dissolved air flotation, is a treatment technology that can address fats, oils, and grease, and other floating materials that would be easily removed with a dissolved air flotation approach.
Okay, and Dan, any comments from you?
No, this is really, it's addressing it looks like an effective solids removal type of technology. You're not going to get the dissolved materials out of it, as Linda pointed out very well, but with the DAF, the GEM system is going to be removing suspended solids, anything that can attach to a bare bubble and float.
Okay, great. Let's pivot off, and Linda, again, you can stay for this if you'd like to. And by the way, the folks from Alpha Laval, feel free to turn your cameras on so we can get you going right away. The more the merrier. But let's spend some time with the panel on the question about, just in general, independent of the two presenters we've seen so far, where's your view of where you get the most bang for the buck? I mean, the generic situation you roll into, what's the first thing to look at to remediate and get the biggest return?
I think, for one thing, chemical usage is an important consideration for cost because that's an ongoing operational cost. The other is energy costs. Aside from just capital, operations and maintenance costs can really drive the cost effectiveness of a solution out of sight.
Sam, any thoughts?
Well, I think, as Linda was pointing out, the difference between, let's say, a 5% solids in your sludge compared to 10%, it sounds like that's only a 50% increase. But in fact, you are removing a tremendous amount of water when you go from 5 to 10% of solids. It's like 90% of the water is removed when you go from 5 to 10%. So it really is a tremendous increase in solids concentration and a reduction in how much you have to haul across the road for disposal.
Gary and Ben, do you have any thoughts about this question, the most bang for the fewest bucks?
Sounds like a great product.
How many do you want?
Nice job, Linda.
Absolutely.
Okay. Well, let's ask this question again. How big do you have to be to take advantage of these technologies? I mean, what's the minimum flow per day before it makes sense? Or before you just say, hey, I can't use this stuff, I'm too small. And then, again, how many multi-degreed engineers do you need on site to run this stuff? How do we address those concerns?
Let me speak real quickly about our operations here at Tillamook. We manage about 300 to 400,000 gallons a day of wastewater, and we have 4 operators kind of round the clock almost. Not perfectly 24 hours, 7 days, but there's some times when we operate without a wastewater operator. So we do have trained operators who operate our system, and they know wastewater in and out, and they have to be licensed by the state. Many companies simply discharge directly to the municipality, and so they don't necessarily have to have trained operators as well. But we're not a pulp and paper company that has millions of gallons a day to treat as well.
Dan, any comment on that? And Linda, I want to hear from you too, but Dan first. Go ahead.
Well, how big do you have to be? Well, it depends on your the cost of your discharge, your cost for your BOD, your cost for your suspended solids, and what the cost effectiveness is of removing that versus letting it go to the city and being charged for it.
What, you mean there's no simple gallon per minute answer? You actually have to put a pencil to it?
Yeah.
Okay, Linda, you had a thought.
Well, you were asking how big do I have to be, and obviously it's return on investment. So, for instance, I have a client out in the Northwest who was spending a large amount of money BOD, TSS, and FOG. And we thought we were going to have to do biological treatment after the GEM system. But by removing nearly all of the TSS and FOG, they were happy enough with the BOD. You know, we were able to reduce BOD, but not get rid of it, obviously. And they were happy with that because they were saving a ton of money.
Okie dokie. Time Nazi must jump in again. Time check. We are 60 seconds over, and Linda, you did a great job of getting us back on schedule. Thanks so much for that.
Thank you.
Wonderful work. And just that quickly, she was gone.